Energy transformation form to science. In this chapter, children will learn the different types of energy, energy as something that cannot be created or destroyed, energy transfers. Now we'll start to learn about energy. First of all, we will see what is energy. Energy is ability to work. Why we say so? Nowadays, people know how to convert this energy from one form to another form and get done their work. Why we need energy? Where we use energy? In our day-to-day activities, we are using energy to walk, to cook, to cycle, to drive our vehicles, in manufacturing products, and to light up your home. So many activities can done by using this energy. So without energy, the life is not easy, right? So simply scientists define energy as energy is ability to work. Now we will see types of energy. Energy can exist in many forms. In our day-to-day life, we meet energy in different forms. So, we are next going to learn what are the types of energy and how we are using them, where are we using them. The first type of energy we are learning here is kinetic energy. What is kinetic energy? The energy in moving objects known as kinetic energy. The kinetic energy depends on mass and the speed of an object. Let's see how. Here, the first picture is a moving car. If the car is moving very fast, the kinetic energy will be high. And if it is moving slowly, the kinetic energy will be low. Now, there you can see one person who is running. Now, the energy stored in that person also the kinetic energy. And also, the other picture is indicating a moving ball. So, the kinetic energy storing in the ball. So, also the kinetic energy can be increased when the mass of that moving object increased. So, we told the kinetic energy depends on the mass and the speed of the object. The second type of energy is potential energy. Potential energy is the energy stored in a body or object. Potential energy we are discussing under three categories. There are three types of potential energies. Number one, gravitational potential energy. With that term, you can understand there should be a relationship with the gravitational force. Right. We will see what is the relationship. The gravitational potential energy is the energy stored in a body or object when is it positioned above the ground. Higher the object or body is from the ground, the greater the gravitational potential energy it has. What's describing here is when an object moving away from the earth up. So the gravitational potential energy is increasing. When an object gradually moving up against the earth, against the gravitational force, the gravitational potential energy will increase. The higher the mass of the object, higher the potential energy it has. Not only that, now think, if we are taking two objects away from the ground upward, if we are taking two objects with two different masses, one is having 2 kilogram and the other one is having 4 kilogram. The mass of one object is 2 kilogram, the mass of other object is 4 kilogram. We are taking these two objects away from the ground about 5 meters high. Now both are at the same level. Both are at the same level. And if we are releasing the potential energy stored in the object of 2 kilogram and the object of 4 kilogram, if we compare, you can see the object with 4 kilogram will contain more potential energy than the object of 2 kilogram. So, for the gravitational potential energy, not only the height but also mass directly affecting on that energy. So the height and the mass directly affecting on the gravitational potential energy. The second type of potential energy is chemical potential energy. The energy is stored in substances and can only be released when there is a chemical reaction. Chemical potential energy can be found in fuel such as oil, petrol, batteries, or even the food we eat. So, in chemical substances, there will be chemical potential energy. To release the energy stored in these chemical substances, there should be a chemical reaction. Then only they are releasing this energy. And the food we eat also containing chemical potential energy. We need energy to do our work. So, to get the energy, we are eating our food. So, this food is containing chemical substances, and these chemical substances are, after some chemical reactions, they are releasing the energy. From that energy, we can do our work. Let's see the third type of potential energy, that is elastic potential energy. It is the energy stored in an elastic object when it is stretched or compressed. They are often found in spring and rubber bands. So the spring doesn't contain any energy. When the spring compressed or stretched only, there will be a potential energy. Elastic energy in rubber bands also the same. When the rubber band is stretched, only this containing the potential energy. The next type of energy is light energy. This is a form of energy that is visible to us. Sun, torch, light bulb, fire, all these light sources are giving us light energy. The fourth type of energy is heat energy. This energy is due to the movement of particles in matter. The faster the movement, the greater the heat energy it has. Heat energy is directly related to the temperature of an object. The greater the heat energy possessed by an object, the higher the temperature it has. Sun, fire, other heating appliances are giving us heat energy. Fifth type of energy is electrical energy. This energy is produced due to the flow of electrical charges. This is commonly used in our daily lives when we are using electrical appliances. The next type is sound energy. This energy is associated with the vibration of an object. It can be a membrane, it can be a wire. Whatever the object vibrate, it is producing the sound energy. Now let's see energy transfers and conversions. How this energy can be transferred from one form to another form, and how to write it, and how this energy transformation take place. Energy transformation. Energy transformation can take place from body or an object to another. It can be represented by energy transfer diagrams. See the first picture in this slide. The person is pushing a car. So, the energy produced in the man's muscles is transferred into the car. That means the chemical potential energy of human man is transferred into the car as the kinetic energy of the car. Here the energy source is chemical energy produced by the food of the man, and that chemical potential energy is transferring to the kinetic energy of the car. The next picture is giving an electrical kettle. What is happening here? The electrical energy transferring from wires to the kettle, and it is heating the coil of this kettle. Then the electrical energy is converting to heat energy. The electrical energy is transferring to heat energy. Therefore, the water is boiling. Let's see some energy transfers. Petrol is burned to provide the power for a car to move forward. Vehicles are moving with fuel. What is the energy in fuel? That is the chemical energy. So the energy source is here, fuel. The chemical energy of fuel transfer into the kinetic energy of the vehicle. The next one is the sun's light is used by plants to make sugar in photosynthesis. To do the photosynthesis, plants need sunlight. So the light energy of the sun is converting to here the chemical energy of the plant. Making a chemical substance is containing chemical energy. So the light energy of the sun convert into chemical energy. Here the light source and the energy source is here the sun. Light is captured by film to make a photographic negative. What is the energy transfer take place here? The light energy of the camera is converted into the chemical energy of the negative. The clothes are ironed with electric iron. Here, the electrical energy is transferred into the heat energy of the iron. We are getting the electricity in our places, so this electrical energy here transfer into the heat energy of the iron. So likewise, in our day-to-day life, we are using lots of electrical appliances and more many other equipments. So when you are using them, just recall and see what is the energy transfer you can see there. Conservation of energy. A very important idea in science, that is law of energy conservation. Let's see what is law of energy conservation. A system which demonstrates the idea of conservation of energy is the pendulum. Pendulum is a mass called bob attached by a string or rod to a pivot point so that the bob is able to swing freely backwards and forwards. So in this picture you can see the bob is fixing with a wire to a point and freely moving from one side to the other side. In this picture you can see bob is moving both sides, highest point and again come to the lowest point. So the highest point, when the bob is at the highest point, it is gaining the maximum potential energy and moving back to the other side. So the potential energy is converted into kinetic energy, and again the other side highest point is getting the maximum gravitational potential energy. So when there's no any friction, this pendulum is continuously working at the same speed. Therefore, at past, this pendulum is used to keep the time because it is continuously moving when there's no any other friction. So they were using this to keep the time. So in most of the clocks you can see this pendulum is there. Energy wastage. What is energy wastage? Not all energy conversions in a system produce useful energy that does work. It's like this. Let's take normal filament bulb. You know, if you keep your hand very close to a filament bulb, but be careful not to touch, so you will feel heat on your hand. Why you feel that heat? The electrical energy transfer into the light energy. Why we are using a light bulb? To get the light. So what should happen here is total electrical energy should transfer to the light energy. But you can feel here actually all the light and all the electrical energy is not converted into light energy. When you keep your hand close to the bulb, you can see heat. You can feel the heat. That means amount of energy is wasting as the heat energy. All the energy not convert into light energy. Some amount of electrical energy is convert into heat energy. That heat energy we are not using at all. Therefore, it's a waste. That heat energy is a waste. So, most of the appliances we are using are like this. All the energy we wanted not convert into that particular energy type. Some amount of energy is wasting without getting any use. See the Bunsen burner. So if you want to heat something in the laboratory, we are using the Bunsen burner. So if you go closer to the Bunsen burner and keep your hand in some distance, you may feel the heat. But actually, we require to boil or heat the object over the flame. But not only the flame, it is not heating only the object over the flame, surrounding also you feel the heat. That means some amount of heat energy is wasting without any use. So that is called energy waste. So the best thing is if we can make the appliances which can convert the total energy of the energy source to use. So if without wasting, if we can use all the energy and if we can completely transfer that total energy, so that appliances will more efficient. Since we were talking about energy wastage, now we will learn Sankey diagrams. What is the Sankey diagrams? The energy conversions that take place in a system can be summarized using Sankey diagrams. Sankey diagram shows both the type of quantity of energy conversions that take place. The quantity of energy is represented by the width of the arrow. From this Sankey diagram, you can identify total energy we are transferring, how much of energy we are using, and what is the amount of energy we are wasting. To represent that, we are using the Sankey diagram. Here you can see a Sankey diagram in this slide. The width of the arrow, the total width of the arrow is showing the total energy we use. And from the arrowhead, it is shows the direction of energy flow. And you can see the useful energy and the wasted energy. So directly from the straight arrow it shows the useful energy. The divert arrow shows the wasted energy. Right. This Sankey diagram is actually drawn for the filament bulb. You can see clearly here the total energy used here will say it is 100%. 100% of energy we are using, but finally you can see the useful energy. That means actually we want light energy from a light. So the useful energy here, light energy, will be only 10%. Out of that 100%, the 90% of energy is wasted as heat energy. So when we are studying this Sankey diagram, you can understand a light bulb is very inefficient. Why is that? Because the 90% of energy is wasted here. Only 10% we are using as the light energy. To indicate this, we are using the Sankey diagrams. Then we will discuss the energy conversions and wastage in the generation of electricity. The electricity we use in our homes is generated from the chemical potential energy in coal. The coal is burned and the chemical energy is converted to heat energy and then electrical energy. You can see this diagram. It is the scheme of electricity generation from coal. You can see first of all here coal. What is the energy in the coal? It is chemical energy. It is chemical energy. So the coal, what we are doing? We are heating the coal. We are heating the coal. So the chemical energy in coal is converting to here heat energy. The chemical energy is converted to heat energy. And from that heat energy, it is boiling water and the steam is sending to the turbine. Right? Steam is sending to the turbine. Now what is happening here is this, because of the steam, turbines are starting to rotate. So that energy is converting to the kinetic energy of the turbine. So this kinetic energy is again connected to the generator. So generator is what is doing? That is the kinetic energy of the turbine converting to electrical energy. So this electrical energy is distributing to our houses. So that is converted to the that is sent into our houses as the electrical energy. So you can see energy transfers here will be 2-3 stages are there. Chemical energy of coal, again the it is converted to heat energy, again the kinetic energy of the turbine, and then the electrical energy. Likewise 2-3 steps are there. Now if we draw a Sankey diagram for this, we can understand the energy we are getting from the coal can we convert totally into the electrical energy, or what is happening at the middle. We can see the wastage after we draw the Sankey diagram on this. Here it shows the Sankey diagram of electricity generation from coal. You can see here the total energy, that means the total width of the arrow is given at the beginning. You can see heat losses to the environment. Heat losses to the environment while it is converting to heat energy by heating the coal. So lots of energy is wasted to the environment as heat energy. It is very close to half of the energy is wasted from the beginning. Then when you move forward, used in power station. So to produce the energy, we want to use some amount of power in the power station. So there you lose more energy, and after finish everything, now the electricity is distributing to the houses. So while it is transmitting, another amount of energy is lost in the transmission. Another some amount of energy is wasting when it is transmitting, and only less than half is delivered to the consumer as the electrical energy. So the useful energy is not from the total energy. If we are taking, it is less than the 50%. You can see that is from the width of the arrow, it is less than the 50%. As you can see from the Sankey diagram, only about 33% of energy are being delivered to the consumer as electrical energy. So to use this energy efficiently, always we have to produce appliances, and we have to use these appliances and plants more efficiently without wasting the energy.